Hey guys, so just like we used the algebra tiles before to visually represent multiplication of polynomials, let's also explore how to use them to represent factoring polynomials. I just think having a visual model might really help us. So what does it mean to factor a polynomial? Well, let's think about what does it mean to factor a number like 210. It means find two other numbers that multiply to give it, right? 210 can be written as 21 times 10. And in theory, and in this case, you actually could even factor even further. You could have 3 times 7, which is 21, and then 2 times 5, which is 10. So, if I said factor 210, you might go all the way to the prime factorization. But in the context of polynomials, at least to begin, the idea is given a polynomial, like the polynomial x squared plus 7x plus 10, all we're trying to find is what two polynomials multiply by one another in order to make this as a product. And I really like using the algebra tiles to model this. And I'll give you a little demo of how we should do this. So what we want to do is we want to find out if we have 1x squared, 7 x's, and 10 ones, what we're going to try to do is we're going to try to arrange all of these into a nice rectangle. And if we can do so, then the length and width of that rectangle will be the two smaller polynomials that multiply together to give x squared plus 7x plus 10. Now here's my suggestion for how you start. Start with your x squared or however many x squareds you got, and then work with your units, and you want to somehow create a rectangle or square or something out of them here. So I'm going to give an example right now. All right, so looking at my 10 units digits, really I could either do a 10 by 1 rectangle or a 5 by 2 rectangle. And the question is, can we now arrange the rest of these x's into these remaining spaces to hopefully make a rectangle here? Well, let's see. I can put an x there, I can put an x there, I can put an x there, I can put an x there. Oh, actually, I think this is going to work. Did a little double tap there to make it rotate. Amazing. Look at that. On our first try, we were able to successfully make a rectangle out of our pieces. So let's take a quick snapshot of that. Let's go ahead back to Notability. Let's go ahead and put this in as a picture. So add photo, all photos. There it is. Let's go ahead and edit it. Let's go ahead and crop it. Cropping it down, cropping it down. Done. And so it appears to me that we have arranged these 1x squared, these 1, 2, 3, 4, 5, 6, 7 x's, and 10 ones into a nice rectangle. What are the dimensions of that rectangle? It appears that this side right here has length x plus 1, 2, 3, 4, 5. Right here was an x, 1, 2, 3, 4, 5. So we have x plus 5. And this side right here was an x, 1, and 2. So x plus 2. And we have successfully factored this polynomial. We found two smaller polynomials that multiply together to give it. Amazing. Let's do some more. So in our next example, we're just going to try to factor x squared minus 9. This one's going to be a little weird. Let's check it out. All right. So x squared minus 9, I'm going to highlight all of these, get rid of them. We're going to have a 1x squared, and we're going to have 9 negative 1s. And note that we don't have any x's at all. What I would say in this case is, once again, start with your x squared piece. Remember, we're trying to build a rectangle. And what I would say is, with your units, whether they're positive or negative, start building out off of that corner right there. And you need to arrange these guys in some sort of rectangle or square here. I think my two options are either a 9 by 1 or a 3 by 3. Let's start with a 3 by 3 just to see how it looks. Now I think that clearly we have not made a rectangle, so we have not fully factored this polynomial, and we don't have any x bars left to kind of fill these in. It looks like we would need some here and we need some here. But check this out. If I take a positive x bar and a negative x bar, ooh, and I put these in, all of a sudden we haven't changed the kind of net area of this soon-to-be rectangle, and this is an acceptable move. Oh, interesting. I'm going to add another x bar and another negative x bar. I'm going to add yet another x bar and another negative x bar. And what we have done is, from our original configuration, we've added some positive x's and negative x's. They each kind of cancel out, if you will. They don't really add any net area. And I think now we have created a rectangle, or in fact, actually, kind of looks like a square that represents how we can factor our original polynomial. Let's take a quick picture of this. And now we have to say, okay, well, what are the two polynomials that gave us our x squared minus 9? Remember that this guy's net area negates this guy's net area, same with these two, and same with these two. So in effect, we have x squared and 9 negative 1s as our kind of grand total area. But what are the dimensions of this rectangle right here? Well, I think we have a x and a positive 1, positive 2, positive 3 on this side. We have an x and a negative 1, negative 2, negative 3 on this side, where you can see that, for instance, x times negative 1 is negative x, and 1 times negative 1 is negative 1. Aha! It appears that this polynomial factors as the quantity of x plus 3 times the quantity of x minus 3. Okay, and you can always check your factorization by just multiplying these together and seeing what you get. And I know you know how to do that. Okay, last one. Here we go. Let's factor x squared minus 2x minus 8. So we've got some negatives again. This is going to be kind of weird. All right, let's take a look. Once again, I suggest starting with your x squared and your units digits. So we're going to have 8 negative 1s. And again, I suggest, as we construct this rectangle, just start with your x squared and your units digits, right, of course, diagonally touching right here, and we're going to try to figure out the rest. Now, right, I have 8 1s here. I could have done an 8 by 1 rectangle. Maybe that would have worked. Or I can do a 4 by 2 rectangle. Let's just start with 4 by 2 because it's a little safer. Now, we know we're going to have 4 x's here and 2 x's here. Now, they could be positive x's. They also could be negative x's. Now, we know that in total, we want to end up with a grand sum of negative 2x. So I think we're going to want 1, 2, 3, 4 negative x's and 2 positive x's, right? There's a total of 1, 2, 3, 4, 5, 6 slots here. And we know that in total, these are going to have to sum up to negative 2x. That's why I think 4 negative x's and 2 positive x's is the way to go. Can we now finish constructing our rectangle? I think that we can. We're going to have to do a double click there. Double click there. Check it out. I think we have successfully built a rectangle whose area is x squared with negative 2x, right, because 2 of these and 2 of these add to 0, minus 8. And we can see that we can find the dimensions really clearly from this. So I'm going to quickly insert this photo. All right, and it appears that, what are the dimensions? It looks like this side right here has dimensions x, negative 1, negative 2, negative 3, negative 4. And this side right here has dimensions x, positive 1, positive 2. So it looks like this polynomial factors as x minus 4 times the quantity of x plus 2. And of course, you can always check by multiplying these two together and seeing if you get this. So I love these visual representations. It really helps me kind of visualize the patterns. And I hope that they help you as well. And so, happy factoring!